Hello learners, myself Namrata Pulje, Assistant Professor in Mathematics, Ganpat Pasekar College of Education, Harmal, Goa. Course name Elementary Combinatorics, topic name Elementary Counting Problems.
Now here in this module we will look at the two basic counting principle. The first one is addition principle and the second is multiplication principle, and also we'll see some examples on addition and multiplication principle. At the end of this module, students will be able to state addition and multiplication principle. Also, students able to solve examples using addition and multiplication principle. Now here we have these two basic counting principle. So first, addition principle. So what it says is, suppose we have R1 different objects in first set, R2 different object in the second set, and Rm different object in the M set, and if the different sets are disjoint, this is important, then the number of ways to select an object from one of the M set is R1 plus R2 up to Rn. So we need to add all these outcomes. Now the second one is multiplication principle. Suppose a procedure is given to you and that can be broken into m successive order stages with R1 different outcomes in the first stage, R2 different outcomes in the second stage, and Rm different outcomes in the M stage. And if the number of outcome at each stage is independent of the choices of previous stages, and if the composite outcomes are all distinct, then the total procedure has R1 into R2 up to Rm different composite outcomes. Now let us look at some examples to understand these two principles more clearly. So here we have the first example. Suppose that either a member of mathematics faculty or a student who is mathematics major is chosen as a representative to a university committee. Then how many different choices are there for this representative? If there are 37 members of the mathematics faculty and 83 mathematics major, and no one is both faculty member and a student. So let us solve this now. Solution. So you can see here we have total 37 members of mathematics faculty and 83 members of mathematics major. So this example is based on the addition principle. So there are 37 ways to choose a member of mathematics faculty, and there are 37 and there are 83 ways to choose a student who is mathematics major. And choosing a member of the mathematics faculty is never the same as choosing a student who is mathematics major, because no one is both faculty member and a student. Hence by addition principle, there are 37, because we have here 37 ways to choose a member of mathematics faculty and we have 83 ways to choose a student who is mathematics major. So therefore there are 87 plus 83, which is equal to 120 possible ways to pick this representative. Now let us look at the second example. Now let us look at the second example. So a student can choose a computer project from one of the three lists. The three lists contain 23, 15 and 19 possible projects respectively. No project is on more than one list. How many possible projects are there to choose from? So here we have the three different sets. That means the first set consisting of 23 projects, the second set consisting of 15 and the third set consisting of 19 projects. And you can see no project is on more than one list, so that means all these three sets are disjoint. So here we can use addition principle. So now the student can choose a project by selecting a project from the first list comma second list and third list respectively. Because no project is more than one list, because no project is more than one list, by addition principle there are 23 plus 15 plus 19, which come out to be 57 ways to choose a project. I hope you understand both this example based on addition principle. Now let us look at some examples on multiplication principle. So what example says here is, two dice are rolled, one green and one red. Each die has 6 faces numbered 1 to 6. How many different outcomes of this procedure are there? And the second one, what is the probability that there are no doubles? No double meaning we should not have the same number on both the die when we roll it. So now here what will be the procedure is? The procedure here is rolling of dice. Now here there are two dice, one green and one red. So rolling a green die will be the first part and rolling of the second die, that is red die, will be the second part. So we are breaking this procedure into two parts. Okay. Now the first, when we roll a green die, so first when we roll green die, there are 6 different outcomes, and the rolling of a red die again will give 6 different outcomes. Hence, by multiplication principle, total number of outcomes are, you can see that when we roll green die there are 6 different outcomes, so 6, and when we roll again a red die it gives 6 different outcomes, so there are total 36 outcomes, different outcomes when we roll 2 dice. So this is the solution for part A. Now the solution for part B, you can see we need to find out the probability that there are no doubles. So we have this two possibilities. So when we roll a green die, okay, we will get some number here, and the same number should not repeat here. So when we roll a green die, we will get some outcome. Okay, we'll keep that aside and we roll a red die. So that number should be the difference. So if we are getting here, let us say 1. Okay, so 1 again should not come here. So we have only 5 possibilities left, right? So this place can be chosen 6 different ways, and this place can be chosen 5 different ways, right? So total number of ways will be 30. So let us write this now. Here, when we first roll the green die, there are 6 outcomes. Now, the outcome we got by rolling a green die is forbidden. So there are 6 minus 1, which is equal to 5 choices we have on rolling the red die. Hence by multiplication principle, the total number of required outcomes equals 6 into 5, which is equal to 30 outcomes with no doubles. But this is not the end of this part B, because we need to find the probability of no doubles, right? So probability of no doubles will be equal to the total number of outcome with no doubles, so that is 30, divided by total number of outcomes when we roll 2 die, and it is 36, right? So this comes out to be 5 by 6. So the probability of getting no double is equal to 5 upon 6. Now let us look at the next example. How many different sequences of heads and tails are possible if a coin is flipped 100 times? Okay, so let us say now when we flipped a coin one time, we have total number of possibility as head and tail. So the total number of possibility will be equal to 2, right? So when coin is flipped one time, the number of possibilities is equal to 2, that is head and tail. Now when coin is flipped 2 times, what are the number of possibilities here? It will be, so the number of possibilities will be equal to 2, because when we flip one coin, that will give 2 outcome. Again we will flip the second time, it will give again 2 outcomes, so that becomes 4, so which can be written as 2 square. When coin is flipped 3 times, the number of possibilities will be equal to 2 into 2 into 2, which is equal to 2 cube. So by similar argument, when coin is flipped 100 times, number of possibilities will be equal to 2 raised to 100. Now let us look at the last examples in this module. Now there are 5 different Marathi, 6 different Hindi and 7 different English books. How many ways are there to pick an unordered pair of 2 books, not both in the same language? So you can see here now unordered pair means you can first pick Marathi book and Hindi book, or you can pick Hindi or a Marathi book, one and the same pair. Okay, so there are total 3 possibilities now of making pair of books. So there are total 3 possibilities of making pair of books. Now the first case is, so case 1 is you can make a pair of Marathi and Hindi book. Okay, now look at this here. You have Marathi 5 different books, right? And the Hindi 6. So Marathi book can be picked in 5 different ways. So Marathi can be picked in 5 ways, and Hindi book can be picked in 6 ways, because there are total 6 different Hindi books. Hence, the total number of ways Marathi and Hindi book can be picked is equal to 5 into 6, which is equal to 30 ways. So we can make a pair of Marathi and Hindi book. Okay, so Marathi book can be picked in 5 ways and the Hindi book can be picked in 6 ways. So there are total 30 ways. Now let us look at case 2, that is Hindi and English book. Okay, now Hindi book can be picked in 6 ways and English book can be picked in 7 ways, right? Now we need to find out the pair of books these both books are from. How many pair of books these both books are from, that is Hindi and English book. So Hindi in 6 ways and English in 7 ways. So hence the total number of ways English and Hindi book can be picked is equal to 6 into 7, which is equal to 42 ways. So you can make total 42 unordered pair of English and Hindi. Now the case 3, Marathi and English book. So Marathi book can be picked in 5 ways and English book can be picked in 7 ways, right? Hence the total number of ways Marathi and English book can be picked is equal to 5 into 7, which is equal to 35 ways. Right. So these outcomes in all these three cases are clearly disjoint, and hence by addition principle, so the outcomes in all three cases are disjoint. Hence by addition principle, the number of outcomes hence by the addition principle, so the total number of outcomes will be equal to, or the total number of pair of books will be equal to 30. In first case it was 30, in second case it was 42, and in the third case it is 35, which is equal to 107. So you can have 107 unordered pair of two books, not both in the same language. I hope you understand all these examples. For reference, you can use this book, A Walk Through Combinatorics, An Introduction to Enumeration and Graph Theory, and the second book you can refer is Applied Combinatorics by Alan Tucker. Thank you.